Hi everyone, and welcome to this week's Centre for Print Research's Lunchtime seminar from Pixels to Print with James Healy. James is our artist in resident. He's been here for the best part of the last month. He is a visual effects supervisor working in commercial and film production. And today he's going to talk to us about animation and 3D printing. The presentation will be approximately 20-30 minutes, and then there'll be some time for some questions afterwards. We are recording the meeting, so hope that's okay with everybody. Over to you, James.
Okay, so my seminar is titled From Pixels to Print, and it's a description of what I do. Simply, I make art and animation on computers, and computers display pictures in pixels. I've been making art on computers since the early 90s, but for the last decade, I've been making things on computers and then 3D printing them. So the title of this seminar is reflects the evolution of my practice, and it's also a description of how I work. So this seminar is going to be split into 3 sections. One, I'll begin by talking about my experience in computer animation. 2, I'll then explain how animation works, the science of animation, and then that will lead me into how I began working with 3D printing. And then 3, I'll use the project that I've been doing here at the CFPR as a case study to demonstrate how I work. So let's get started. 1, computer animation. So I began working with computers in the early 90s when I was at school, and that led me to study at the National Centre of Computer Animation, which is at Bournemouth University. After graduation, I began working professionally in commercials, music videos, feature films, all kinds of things. I have a show reel that collects together some of the highlights of that work, and I'm going to show you an extract now. We had some of the limitations of Zoom there. So all of the animation in that reel was created digitally on a computer, but regardless of the technology, the fundamental science of animation hasn't really changed since its inception, which brings me to part 2 of the seminar, which is not the show reel again. Classic. How does animation work? So how does animation work? A series of sequential images are played in rapid succession, one after another. Here's a sequence of a tiger running. We can read that it's running, we can understand that it's running, but we can't actually see it moving. In order to do that, we need to display those pictures one after another. So let's give that a go. So here I'm playing the frames at 2 frames every second, so 2 pictures every second. And we can see it moving, but it's a bit steppy. We don't really get it. Our brain's still having to fill in the gaps. So let's try that a bit faster. So here it is at 24 frames per second, and now we've got the jazz. It's running. We see it as running. We don't really perceive those still frames anymore. We just see a moving tiger. So people have been watching animation on screens for about, well, over 100 years. The first screen animations were projected in cinemas, but there were a set of devices that came before cinema that allowed people to watch animation, the most famous being zoetrope. I happen to have purchased a zoetrope from a popular online vendor. You can see it's basically a cylinder with some slots in. Currently doesn't have any animation. So if we take those tiger drawings and lay them out in a strip, there's 12 of them here, which coincidentally works with the 12 slots of the zoetrope. And we put that animation into the zoetrope, we should see motion when we spin it. Okay, presto. So back to still the zoetrope. You might be wondering what those slots are on the zoetrope, and I wasn't entirely honest as far as how animation works. And in between each frame, what you need is a black flash. So without that black area between the slot, what you'd get is just a blurry image. A cinema projector actually does that. It shows an image, then it shows a black frame, then it shows an image, and so on and so forth. Your screen and a TV, a laptop, they all do the same thing. So to get animation, you need a series of sequential images. You need to display them at 24 frames per second, and you need a black flash in between each of those frames. So given that we're at the Center for Print Research, if you can watch animation with a 2D printed strip, it's not a huge leap of the imagination that you could do one with a 3D printed strip. Here is an animation of a disc that I made. It's not a tiger, it's just a simple disc. But I modeled that in 3D and animated it in 3D, which means that I can 3D print it. Here it is printed out as a strip, as a 3D version of that tiger strip that we looked at earlier. And if I put that into my zoetrope, should see animation. So the reason that I'm showing you animations in zoetropes is that having worked with computers for some time, I found that I began to miss working with real objects because everything on the computer is virtual, everything's on a screen. And 3D printing, specifically making zoetropes with 3D printing, provided a bridge between the virtual world and this more real, tangible world. This is once again, I have clicked the wrong button. This is a animation that I've 3D printed. It's titled Crab Park. It's essentially the same principle as the disc animation that I showed you. I put that in a zoetrope. I get animation. So it's exactly the same principle as before, which is a sequence of objects, and we're looking at them at high speed with a moment of black in between. So there's an overview of how I began using 3D printing via 3D animation, or how I went from pixels to print. I'm now going to talk about the project that I've been doing here at the Center for Print Research, and this will give me an opportunity to explain how I work, show you some of my workflows, show you the practical pixels to print. In order to explain how this works, I'll need to give you some context. So the artwork that I'm developing here is called 20 go to 10, and it's a sequence of 5 3D printed sculptures. They don't move, they're not a zoetrope, but they are a sequence. Here's a concept of the sculpture. So the viewer needs to read the motion in their eye, their mind, like they would a storyboard or a comic strip. So in many ways, it's a little bit like the tiger that we were just looking at prior to putting it into the zoetrope. In this artwork, I'm essentially working backwards. So instead of making something, printing it and making it into an animation, I'm taking an animation, taking frames of that animation and printing it. So I'm now going to go through the workflow for that. So let's have a look at the animation to have a look what our target is. This is the final product. And I'm now going to talk about how I get to that. So I begin with a curve, and that curve has points on that are spaced out a quarter of an inch. I take those points and I animate them around the curve like this. I then take that animation and I revolve it around an axis like so, and this gives us the torus. And because the curve that I revolved around had animation on it, the animation is being retained, so the torus is moving. So that leaves only one more stage, which is to spin it around the axis, which I do here. See, I've put a line on there just so you can see it because it's quite busy. So if we look back at our target, our end product, you can see I've got the underlying animation. I'm just missing those fins. And the way that I do that is that I take my underlying torus and I randomly define segments on there. There's 5 different segments indicated with 5 colors, and those 5 segments each have a different length. So I should step through those like so, and they begin at quarter of an inch and they grow all the way up to 2.5 inches. I leave some segments remaining to give a little bit of contrast. If I apply the underlying animation that we just looked at to these fins, we should be pretty close to our end product. There you go. So making something on the computer with the intention of 3D printing it, I'd say designing, building the animation or the model is about half of the work, and the second half of the work is organizing that data so that you can print it. There's basically 3 considerations when you're 3D printing something. 1, the orientation of the print. 2, how you're going to finish it. And 3, how you're going to put it together. So I'm going to go through those. The first one is orienting the print. So I'm using an FDM printer here, and it prints in layers from the bottom upwards. This is a time lapse from the Bamboo website. This is a printer that I'm using. You can see it's printing in layers of plastic all the way from the bottom to the top. It doesn't print that fast. The time is on the left in minutes. So because I'm printing from the bottom upwards, the main consideration is the supports, how I'm going to support things, which relates to orientation. I I keep clicking on the wrong button. So let's have a look at an example. So here we have a unicorn, again from the Bamboo website. And you can see that if we're printing from the bottom upwards, the legs are going to support themselves. But some of the areas, they're not going to support themselves. So these areas here, his head, his belly, and his tail, if I'm printing from the bottom upwards, there's nothing to support them. So the Bamboo software, the slicer software, will deal with this, and it puts these little supports in. Well, problem solved, but kind of not really, because what happens is when you break those supports off, they leave a mark on the surface. And also often it's not really practical to leave those, to have those supports, because maybe the supports are on the print itself, like they grow from the print itself. So then you can't remove them. So really what you want to do is just avoid having any supports. So if we look at look at my sculpture that I'm developing here, you can see that all the fins move outwards from the shape. So if I want to print this without any supports, I can take it from the side, slice it down the middle like this, lay each piece on its back, and then I can print it from the bottom upwards without any supports. Problem solved, sort of. So that leads me, press the wrong button again. That leads me to the next section, which is print finishing. By finishing, I mean how the final print looks. So is it painted? Is it varnished? So on and so forth. For the most part, what I try to do is give each print its own color. It just makes it a lot easier to manage. And I quite like the aesthetic that comes with that, because it makes it very clear what you're looking at. Because this is a really complex shape, I'm actually going to use the color of the plastic. So I'm going to print the sculpture in two colors of plastic, red and pink, rather than spraying it, which is what I normally do. So I now need to take that print, which I split into two, and then split it into two more again, so that I've got the two colors. So I split it in the middle so I can print it on its back, and then I take that print and cut it into two. So I've got the red and the pink, which is 4 prints. But because there's 5 sculptures, I've now got 20 prints, which is starting to get a little bit complicated to manage. So in order to deal with that, I have a plan, which leads me to assembly. So let's have a look at what I do in 3D. So this is my red piece that I'm ready to print on its back. And you can see that at the bottom of the screen, it says red 15 plus. And that is an index for the print. Each one of these prints has an index. This one is frame 15, it's plus, so it's on the positive side, and it's to be printed in red in case there's any mix-ups there, which definitely do happen. Because I've got so many parts, it can get a bit complicated, first keeping track of them, but then also making sure that they fit together correctly. So I also model in these little alignments. You can see them in green there, and those allow me to kind of IKEA style make sure that everything goes together. So here's a time lapse of me assembling my a prototype of the sculpture. See, it's in 4 parts. Those are the little alignments going in. Put the fins on as well. That takes us fairly neatly from pixels through to print and concludes my seminar.